let's consider another example. So in this example, we want to find the volume of the solid in the first octant that is bounded by the cylinder x squared plus y squared plus 4. The half cone c equals to square root of x squared plus y squared and the xy plane. Okay, so this half cone, consider the positive c coordinates, and this is a cylinder with radius 2. Okay, let's draw this domain first. We have a cylinder with radius 2, something like this. Okay, and then we have this half cone. Let's say this is the origin. We have a cone like this. Okay, now let's locate the x and y axis. This is the x-axis, this is the y-axis, and here we have the c-axis. And our goal is to find the volume of the solid bounded by the cylinder x squared plus y squared equals to 4, and the cone c equals to square root of x squared plus y squared, and the xy plane. Okay, now, so basically, we have this cone. Now we need to find the volume in the first octant. Okay, good. Okay, so if I consider this solid E, it should be over here. It should be in the first octant. This is my solid E. Okay. Now let's find the equation of these two surfaces in terms of the cylindrical coordinates. We know that x squared plus y squared equals to r squared. So we have r squared equals to 4, therefore r equals to 2. This is the equation of the cylinder. Now equation of the half cone, c equals to square root of r squared, therefore c equals to r. Okay, now our volume element is over here. That's dV. Okay. Now here is a better picture that I got from Mathematica. That's a solid. If I consider the first octant, you should see something like this, and this part is our domain, because we want to find the volume in the first octant. That's your E. Okay, so now we know that volume equals to triple integral of 1 dV over the solid E. Now in cylindrical coordinate system, dV equals to r dc dr d theta. Okay, now let's find the 6 limits. The inner integral corresponds to the c variable. Lower limit of c is given by the xy plane. So on the xy plane, z value equals to 0. The upper limit of c is given by this cone. In general, upper limit of c is given by the surface of the cone. Equation of the cone is c equals to r. Therefore, the upper limit should be r. Okay. Over a domain D. Now your domain D is this region. That's your domain D. It's on the xy plane. So if you look from the top, this is an eye. If you look from the top, you will see your domain D. Domain D, it's in the first octant, so we should consider the first quadrant. This is your domain D, and radius of this circle equals to the radius of the cylinder, which is equals to 2. Okay, so now the volume integral becomes this middle integral corresponds to the r variable. R goes from 0 to 2. Now the outer integral corresponds to the theta variable. Theta goes from 0 to pi over 2. 0 to pi over 2. Now let's do this integral. Let's evaluate this integral. 0 to pi over 2, 0 to 2. My first variable of integration is c. My first variable of integration is c. So we have to treat r as a constant. So now we have r times the integral from 0 to r of 1 dc dr d theta. Okay, integral of 1 with respect to the c variable equals to c apply the upper limit and then the lower limit. Okay, r minus 0 is r times r is r squared. So we have r squared dr d theta. If you integrate r squared, you should get r cubed over 3. Lower limit of r is 0, upper limit should be 2, then d theta. Apply the upper limit, which is 2. So r equals to 2. So you have 2 cubed over 3 minus the lower limit will give you 0, because r equals to 0. So 0 to the power 3 is 0. Theta. 2 to the power 3 is 8. 8 over 3 is a constant. And we can pull out a constant from the integral sign. So now our last integral corresponds to 1 d theta. Integral of 1 with respect to the theta variable is theta, or variable of integration. So we have 8/3 times pi over 2. If you simplify this, you should get 4 pi over 3. Okay, so with this I've finished the second example, and here we calculate the volume of this solid portion, this part.